This is lesson 5, and I split section R.5 into 2 parts. This is rational expressions. Now, when we talked about rational numbers earlier, what did we say rational numbers are? That's right, they're like fractions. So this expression is like a polynomial over a polynomial, or like a polynomial type of a fraction. Alright, and so we're looking at different types of problems in dealing with rational expressions. Here we have a rational expression where we have AC over BC. Here, this would be like A times C and B times C. The C's cancel out, simplifies, and so we have A over B. So if we can simplify rational expressions, we want to do that. Okay? Multiplication. Well, just like multiplication with numbers, when you're multiplying polynomials, A times C is going to be AC, B times D will be BD. Okay, you're going to see that properties with polynomials are really not much different than properties with numbers, as far as multiplying, simplifying, adding, subtracting, like that. Here, dividing rational expressions, we have to take the second term and do what with it? Basically, we're taking this second rational expression, right? We can't just work with it the way we have it. What do we have to do with this second expression here? Flip it, right, and multiply. So the D's on the denominator, now it's on the numerator. So if you have numbers that look like they can cancel, cannot cancel in division. You have to wait till you flip it, and then you can see if you can cancel. Okay? So in other words, if this was a B here, cannot cancel these until you flip it, and then you see you won't be able to cancel them anyways. Okay, so this is A over B times D over C. This should be an equal sign here. Equals AD over BC. Alright? And so there's more where we're going to get into adding and subtracting and that, but that'll be on the next lesson on rational expressions. So with that, let's take a look at some problems. This is lesson 5, R.5a. And this is rational expressions. Alright, let's say that we have this. Let's say we have a polynomial such as 36y squared plus 72y over 9y squared. Okay, now we said earlier, in the last couple of lessons back, when we're simplifying, what can we not have to where we cannot cancel when we have something in the expression? Okay, what can we not have? In other words, something something is preventing us, we cannot cancel the 9 into the 36, for example, or the 9 into 72, or the y's, we cannot cancel those. Why? There's one reason. Or one thing in there that prevents us from doing that. The plus, that's right. Cannot cancel when you got that plus or minus there, right? You can only cancel when you got multiplication or division. But we can do something. What can we do here? And then simplify. We can take these terms and we can split them. And then we can cancel. There's one way. Another way is to factor, but splitting them and then canceling, that tends to be a method that students tend to prefer. So we take this and we put it as 36y squared over 9y squared plus 72y over 9y squared. So it kind of follows the principle, if you had 2 over 4 plus 1 over 4, you get 2 plus 1 over 4, right? So that's 3 over 4. So basically, what we're doing here is we're going backwards. Okay, and then simplify. So now, the 9 can cancel into 36, right? And then what does that leave us with? 4. And then the y squares, they can cancel, they go to 1. 9 goes into itself one time. Okay, 9 can go, so that would be the same thing as if we said just 4 plus, so 9, that can go into 72 how many times? 8 times, right? And then the y can go into y, so that would be plus 8 over y. And that's our answer. Okay? Questions with that? Alright, now one like this, where you have, now this one here, this last one, you just had a single term.